Hi all, welcome to Tele9751. The topic for the day is optical switching. The main topics that will be covered in the 5-minute video lecture is optical component, optical switching, MEMS, wavelength routed networks, and packet switching, and how to deal with contention. I hope everyone knows what an optical fiber is and its operation principle. It consists of three important layers. They are core cladding and a plastic jacket protection. The core is the innermost layer and has a diameter ranging from 8 to 62.5 micrometer, and the cladding around 125 micrometer. The principle of operation is called total internal reflection. It occurs at the core cladding interface and when the refractive index of the cladding is less than the refractive index of the core. One more condition is the angle of incidence of the light should be greater than the critical angle. Moving to the advantages. They are immune to electromagnetic noise and low attenuation occurs for wide bandwidth. Moving to erbium doped fiber amplifier. Why are they used? The reason is many fabrics exhibit high loss, so it should be amplified through EDFA filter after switching in order to prevent the loss. It can amplify signals which are 30 dB and above, which have broad bandwidth and works like an electronic on or off switch. Transceivers and receivers. They are mainly used for broadcast and select networks. Initially, the tunable laser emit laser lights and they will be passed through the broadcast medium, where they are multiplexed at combiner and passed through the fiber and multiplexed at the splitter, and then to the tunable filter, and then to photodiodes. The disadvantage of it is that it has poor signals. The poor signals will produce due to quality of the signals will be poor due to broad splitting. So optoelectronic networks, they are found by replacing wired links with fiber, but the disadvantages are they are so much expensive and switch throughput will be limited. So the next option is optical networks. They provide high transmission speed, low cost, they are environmental friendly and provide transparency. They also have some disadvantages. Their signals are amplified, not regenerated. Error rate monitoring is hard. MEMS. They are called as microelectronic mechanical system. It consists of mirrors and are implemented using photolithography. It involves precise positioning of mirrors and it integrates mechanical system with control electronics. Routed networks. They are motivated by wavelength division multiplexing and the components are wavelength selective. There are they can be classified into two typically. One is optical demultiplexing and other one is static demultiplexing. In optical demultiplexing wavelength, the wavelength is dropped and then added. They have got many access ports. Moving to static demultiplexing. Here the wavelengths are differentiated and are assigned to ports. It can be done by either by refraction, diffraction, using an interface or by using the filter as shown in those figures. How to control refractive index? It can be controlled by using an electric field, sound, or by using heat. So you'll be asking me a question. Can't we use, can't we build a switch from filter or gates? Yes, we can. It will consist of a, if, if we build one, it will be consisting of a splitter, combiner, and a filter. Each input will be split into n outputs by the splitter, and the combiner will only have one active input. Then the EDFA filter amplifies the signal. Photonic packet switching. Here the packets will be in the form of payload and control. The payload alone passes through the fiber delay line, but the control packets will have an optoelectronic conversion and then will pass through the electronic control network and then to the output. How to deal with contention? If it is in the time domain, optical buffer can be used, while if it is in space domain, deflection routing will be used. Optical buffering is used when long loop fibers forms delay lines, but it creates attenuation in delay lines and complexity. It can be overcome by using fiber delay lines, programmable fiber delay lines, or active recirculating delay lines. Moving to space domain, deflection routing. If two inputs, blue and red as shown in the figure, are choosing the shortest path, whereas the orange is on the longer path, When they get deflected, links becomes passive uh, delays line buffers. But the advantage of this method is that the better service can be provided to the original high priority packet, and it escalates priority after deflection. So this is for today. Thank you.